It is given that f of x is equal to this. Express that f of x in the form of a over 3 minus x plus b over 1 plus 3x, where a and b are integers. Find the first three terms of the binomial expansion of f of x in this form, where a, b and c are rational numbers. State why the binomial expansion cannot be expected to give a good approximation to f of x at x equals 0.4. So I've got the question paraphrased here then. So let's have a look at partial fractions first. So a, 7x minus 1 then, over 3 minus x times 1 plus 3x is the thing up here. I've put them around the other way because we let it equal a over 3 minus x. It's easier on the eye, written in this form, plus b over 1 plus 3x. So I've written it, the product, in reverse to what's here, because it's easier on the eye when you look at this partial fraction. So here, multiplied by the denominator then, gives, so we got 7x minus 1 on the left, and then cross multiply, a times the 1 plus 3x, plus b times the 3 minus x. Now let's put in suitable values. Let's put in x as 3. See what we get here then. This will go to 0. 21 minus 1 is 20. Put 3 in. 3 3s are 9 plus 1 is 10. That's 10a. So that tells us move the 10 from times to divide. 20 over 10 is 2. So a equals 2 then. Now we'll put in x is equal to minus 1/3. The other bracket will go to 0 then. Minus 1/3, so it's minus 7/3 minus 1, which is minus 3/3. So minus 7/3 minus 3/3 is minus 10/3. So let's write that down straight away. This will be 0, and then it's 3 minus minus 1/3, which is plus 1/3. 9/3 plus 1/3 is 10/3. So we can see that b is minus 1, can't we? Clearly. Okay, just divide by 10/3 both sides and we see b is minus 1. Okay, good. So without further ado then, this is equal to 2 over 3 minus x plus b minus 1 over 1 plus 3x. So there's the answer there. Find the first three terms in the expansion of f of x in this form here. Okay, so find the first three terms in the binomial expansion. So b, part 1 then, fx is equal to a 3 minus x to the minus 1. A was 2, wasn't it? So let's put 2 in here. 2, and then minus 1 plus 3x. Minus 1. Let's take a 3 outside, and it's going to be, when we take a 3 out of the bracket, well, I'll do it long-windedly. That would be 1 minus x over 3 then, wouldn't it? All to the minus 1, minus the 1 plus 3x to the minus 1. Now we've got this product, all to the power minus 1. Well, that will be 3 to the minus 1, which is 1/3, so that's 2/3 then. And then it's this to the minus 1, isn't it? Minus the 1 plus 3x. It's minus 1. Okay, that's equal to 2/3. 1 plus n minus 1. Use a binomial theorem. nx minus x over 3 plus n minus 1 x squared over 2 factorial. So that's up to our x squared term for this one, plus dot dot dot. So that's this one done. Minus, and then we've got 1 plus nx minus 1 times x, 3x, plus n n minus 1 x squared over 2 factorial plus dot dot dot. So let's see what we've got. So we've got equal to 2/3. Let's work out these terms. Minus times minus 1. We got a 1 here. Then we got plus x over 3. And then we've got 1, 2, 4 minuses, so it's a plus. The 2 will cancel with the 2. And here we got x squared over 9. Okay. And then we've got minus 1 minus 3x. Minus times minus is a plus. The 2's cancel once more. We get 9, 3 times 3, 9x squared. So let's see what we've got then. So we got 2/3 here, minus 1 is minus 1/3. That's the numbers. 2/9. So we've got plus 2/9 minus plus 3. That's 27 over 9. Plus 2 more ninths is 29 over 9. Type it in the calculator if you need to. The next one will be 2/27 minus 9. 2/27 minus, because the minus comes through, 9. 9/27s, 9 20s are 180, 9 7s are 63, 243 over 27x squared. Oh, and it should have been plus dot dot dot, shouldn't it? So that's equal to minus 1/3 plus 29 over 9x. 2 take 243 is minus 241 over 27x squared. There's the expansion up to that. Now, that's valid when, well, first of all, the range, this object here, modulus of that must be less than 1. So x over 3 modulus. Modulus must be less than 1. And here, 3x, that modulus must be less than 1. So this tells us x is less than 3. Is greater than minus 3, this one. And this one tells us that x is less than 1/3. Is less than minus 1/3. So, range of validity is, this lies inside this one, so we take the stronger condition. So that's the range of validity then, where this expansion is valid. So a good estimate when x is 0.4, part 2. X equals 0.4 is outside the range of validity.